Who's ready to math? Woo! All right, so we have another amazing installment of Algebra 1 with Mrs. Cooley. I totally need some theme music or something going on because, let's be real, why not? Okay, so in this lesson, we are going to specifically talk about functions that we've kind of already been talking about and how we use them to label and for the different features and things that we're going to use with it. Okay, so let's go ahead and take a look. So a function satisfies the statement that every input has one specific output. We've already kind of taken a look at that and taken these relations. We've been looking at the x values and kind of asking the question, is it a function? So in all of these that we're going to be focusing on, they are functions. They're already established. And we're going to specifically then be looking at the rules that get applied with these functions. So it has this specific idea, this rule, and you guys already have done this. So in the past, you have this table and it says what's happening to the value. That's a function. All right, so functioning means it's this machine, it's this thing that's happening to the input to create the output. That independent and dependent variables that we're going to be talking about that you guys have also possibly visited in science. So it's all of that same relationship and how can we write these answers and kind of discuss what's going on. All right, so in this first example, I have a table. Ooh, look at that table. All right, we have the input, the x of 2, 1, 2, 3, and 4. And we have the output of -2, -1, 0, and 1. So the question is, what is happening to the input to create the output? Okay, so I put in the number 1 and I get the -2. So there's two rules of thoughts with this. So I see that it's a decrease. All right, so I could be adding a negative. I could be just subtracting. So how do I get from 1 to -2? So it's 1, something's happening to it, and I get -2. Well, you can say, well, I'm doing 1 minus 3. So I could be subtracting 3. Or some of you guys might say, well, I'm doing 1 times -2. Both of these, you're absolutely correct. I would be getting -2 with it. The problem is that same rule has to apply to all 4 of these in this column. So we're going to check this next one. So we're going to say, okay, well, if I have 2 and I'm going to subtract 3 from it, well, I do get -1. If I do 2 times -2, well, that produced -4, which is not -1, so that is wrong. So now I might try this again, and I could say, well, 3 minus 3, yep, it's 0. And 4 minus 3 equals 1. So the rule that's applying is I'm subtracting 3. So now what I can do is I can take out this 1, 2, 3, 4, and I can put this x for it. So it was x. What happened to it? Well, we subtracted 3, and then all of these values on the other side of the equal sign are the y's. So the rule of this table is that you take x, you subtract 3 from it, and you get y. Now, often you're going to actually see it written as y equals. So we're always going to lead with our y, and that's when we would put our x minus 3. So in this case, the rule is x minus 3. Now, some of you guys won't have to write this work, but if this helps make sense and help you write your rule, please feel free to do it. Now, for whatever reason, that keeps focusing and it's driving me bonkers. So let's try that again. See if that works. Change that setting. All right, so let's go ahead and you do a problem. So we have this you do of these coordinates, and I want to know what is the function rule that's happening to them. All right, so you could have made this in a table and said 1, 2, 3, and 4 are all of your x's. And 3, 6, 9, and 12 are all of your y's. So again, the question is, what is happening to x to create y? Well, I can say that I'm adding 2. Or I could have said I'm multiplying by 3. Both of those would work. So when I look at my next one where I'm inputting 2 and I'm getting 6, if I add 2, well, that does not equal 6. And if I am multiplying by 3, well, that does. And I can continue then to check this out. 3 times 3 is in fact 9. 4 times 3 is in fact 12. Therefore, I am multiplying by 3. So we have x times 3 equals y. Now this is really yucky looking, so we need to make sure we're writing it correctly. That y equals 3 times x. All right, so now knowing that, that's kind of like the intro, if you want to say, okay? So that's kind of how we set up these equations, how we create these rules. But now we actually have to look at the specifics of it. So you're going to go ahead, depending on where you're on your paper, you can put a dot, 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 or a dash, dash, dash. If you're on a new page, you're just on a new page, however you want to look at it. So we're now going to take a look at our concept of independent and dependent variables. So again, many of you guys have already learned this in science, which actually benefits me. Woo! We should be able to go through this really quick and easy. All right, but just to remind you how things work in math, the input of the function is the independent. All right, the x. All right, the independent, the I don't gotta listen to nobody else, I'm gonna do my own work, the independent, okay? Which means then the output of the function is dependent. So it depends on that independent. So the output, the result, is the dependent. All right, so and then I just kind of said it out loud. The output depends on the input. So by me plugging in numbers, I get a result. So that output, you only know the answer after you put something in. Okay, so the input is x, the output is y, the input is independent, the output is dependent. Okay, so I know it's a lot of vocabulary for all the same thing. You're like, why can't it just call it the same thing? It all depends on the topic we're working in. All right, so let's go ahead and practice. We're going to practice identifying which component is independent and which component is dependent. Now, I'm going to be completely honest with you. There's a reason why I'm in math. I am not a wordsmith in any capacity of the way. So some of these I have to think really hard about and go, which one is going in to which one is coming out? And that's how I have to decide my independent and dependent. And then I will always use the phrase, which thing depends on the other. All right, so let's take a look at this first example. So we have in the winter, which is what we are actually approaching, the electricity or more electricity is used when the outside temperature goes down. All right, and as we would hear, fact. All right, that is a fact. In the winter, I use more electricity as the temperature goes down. I mean, I guess that would be the same with the temperature of, or using my air conditioner, right? The temperature goes up, I use more electricity. Again, in the winter, more electricity is used when the outside temperature goes down. So the first thing we have to decide is actually what are two things we're using? So yeah, I'm going to ask the question independent or dependent. But the question is, what even gets written on those lines? So you could use that technique of circling. So in the winter, well, that's not a mathematical anything. More electricity, I could be using electricity, is being used when the outside temperature goes down. All right, so I should be able to see I am using electricity and I am having my temperature. So now we need to kind of answer the question. The blank depends on blank. So if it's me, I'm thinking, well, does the temperature depend on how much electricity I'm using? Because that would be really awesome. If I use really like no electricity, is that perfect weather outside? We know that's not true. That would be awesome, but unfortunately not true. So we would say the electricity depends on the temperature outside. So which thing don't I have control over? Well, I don't have control over the temperature, which means the electricity depends on the temperature. Make sense? Definite maybe? Let's see what this next one says. So we now have an example that says the cost of shipping a package is based on its weight. So again, I ask the question, what are the two things that I'm actually measuring? Well, I'm measuring cost and I'm measuring weight. So which one depends on who? The blank depends on blank. So does the cost depend on weight, or does the weight depend on the cost? Well, we would note the cost depends on the weight, which means cost is the dependent, and he depends on that independent weight. Because I can have any weights. That's what makes it independent. It does not rely on anything else. Okay? So let's go ahead and have you try these two you-dos. So we have the faster Tom walks, the quicker he gets home. The company charges $10 per hour to rent a jackhammer. So again, what is the independent and what is the dependent? All right, let's take a look. So the faster Tom walks, the quicker he gets home. Is there anything I can circle? Faster he walks, the quicker he gets home. Well, I can say that we are talking about the speed that he's walking. And I can also say that we are talking about the time for home. So which one depends on which? Does the time to get home depend on how fast he's walking? Or does how fast he's walking depend on his amount of time to get home? Well, we plug in how fast he walks. And then we get the time to get home. Now notice I switched where the I and D were. Hopefully that didn't confuse you too much. All right, a company charges $10 per hour to rent a jackhammer. All right, so I'm inputting the number of hours and the cost will then be my dependence. Is that what you got? All right, so the next component we're going to be talking about is called function notation. So this is kind of a different gear of what you're going to have to do to kind of use functions. So independent and dependent variables were great, understanding what gets input and what gets output. But now it's how do we write that specific answer? All right. So we are going to now kind of take a look at the concept of function notations. All right. And so you need to understand the word notation simply means to write. So we have scientific notation and we have standard notation and we have notation simply means to write. So when we see the words write this in function notation, all it's saying is it's a way to write functions. Write the function. Okay, so please don't overthink this. It's only going to be used when we have function rules. It's only going to be used when we're just explicitly looking at something. So we're going to kind of take a look to start on what in the world does function notation even look like, sound like, and visually see. All right, I already said looks like, right? So visually see, yeah, because that's the same thing. All right, so first off, we need to remember if X is the input and Y is the output, you can use function notation to write this rule. Weird, right? Function notation, a way to write functions. So if I have an input and I have an output, that's a function, which means I can use function notation. All right, so here is our first fact. The dependent variable is a function of the independent. I plug in X, function happens to it, I get Y. Okay, so that means I can write it. So dependent is Y, is the word is, a function of, and independent is X. It's doing that weird focus thing again, guys. What's it doing? Sorry. Right? So because of this, we can change it again. Y is Y, is an equal sign. A function of is the letter F, and X is X. So function notation literally means replace Y with F of X. Equals. They are the same thing. So I can take out Y and I can put F of X in, which is why function notation is what it is. Instead of writing Y for output, I put F of X to represent that this is a function. That when I plug in X, I do something to it and it creates Y. So let's specifically take a look at what this actually means. So now that Y is F of X, instead, sorry about my little typo there, of writing Y equals, we will use F of X. So F of X means Y means F of X. It's simply function notation. It's a specific way to write functions. All right, so take a look. I did this first one for you. If Y equals X minus 3 that we realized in that very first example that we did, we would now write it as F of X equals X minus 3. We take out the Y and we put in the F of X. So if that's the case, and we have our second example of Y equals X times 3, or 3X, how would we now write that in our function notation? Right, it would be F of X, so F parentheses X equals 3X. Take out the Y, put in F of X. All right, so let's now see that. So this is function notation. So now let's try it. So we have this example of Amanda. She's babysitting, and she's charging $5 an hour. So she's a pretty cheap babysitter. I'd hire her. So the first thing we have to do is we have to write our rule. What is happening? So we input hours. So hours has to be our X. And we get our amount of money, which is Y. So please, this is separate from the 5. So we would get Y equals the amount of money she charges is what times our hour? Well, I'm getting $5 an hour. So we would write Y equals 5X. But again, I need this in function notation, which would be F of X is 5X. Again, as we wrote, the dependent variable is a function of the independent. So we are seeing that $5 every hour is what is going to be produced. So let's try this next one. I have the admission fee to the carnival is $8. So I'm paying $8 just to get in. And then each ride is $1.50. Each ride is $1.50. So I know my variable has to go with that. So the question is, how much am I going to have to pay? So my f of x, my result, my dependent, depends on paying $1.50 every ride that I want to do, plus the $8 just to get in. So if I don't want to ride any rides, I plug in 0. It costs me $8 to get in. If I want to ride one ride, it's $9.50. I want to ride two rides, it's $11. The variable does not go with the 8 because I'm only paying it one time. Okay. So let's go ahead and have you try one. The amusement park charges $6 to park plus $29.99 per person for a ticket. So the question is, what is the function? Right? So my function, f of x, has to be that $6 parking ticket plus the $29.99 per person to get in. So my variable should be with the $29.99 because if I only have 8 people, if I have 2 people, if I have 1 person, this is what I'm paying. Now, if there's more than one car, yes, you're going to do that, but we'll say these are the amount of people that are riding together. All right. So the last component of this, not that, this, is in our real world problems, we have to focus in on the domain and the range. I'm going to put my chair up. I keep slouching in the video. Weird. All right. So we need to choose reasonable. So remember, the domain is my x and the range is my y. So when a function describes a real world situation, going to an amusement park, measuring the length, walking distance, time passing, every real number is not always reasonable to use. Sometimes I'm not going to use negative numbers. Sometimes I'm not going to use fractions. All right. Sometimes they set parameters and they say there's only 7 days in the week. Well, I can't have 8 days because I'm only working 7. So we have to understand that it has to be reasonable. When a function describes a real world situation, every number is not always going to be reasonable. All right, so let's take a look at what that actually means. So we have Manny here. Manny is in a play. He has the lead and he wants to have people come. So he's already sold $20 worth of tickets. All right, he said, you want to go? Do you want to go? Do you want to go? And he sold tickets. He has 4 tickets left to move, left to sell. And each of those tickets costs $2.50. Okay? So our first thing we need to do is, what is the function rule of this? Because we need to figure out what else he has left to do. So we have to specifically look at, well, what is it that we need to write? Well, we need to know that his f of x, his function, his y, his result, his dependent, is dependent on the $2.50 per ticket that he's dealing with. And then the fact that he already sold $20 worth. So the question that's kind of being asked is, how much money is he earning for this play? He wants to know what is left. How much money is he actually bringing in for these tickets? So then it says, give the domain and range that's reasonable. Well, it says I only have 4 more tickets left. So will it make sense that I plug in 6 tickets? Would it make sense to plug in 8 tickets? Would it make sense to plug in -5? What about 4.5? There is only specific numbers that I can use to actually plug in to make this make sense. So the domains of this, the numbers that I would plug in, would be if I sold 0 tickets, because that's allowed. Maybe I max capacity. I don't have any more family or friends that want to go. Maybe I sell 1 more ticket. Maybe I sell 2. I could sell 3. Or I can sell all 4 of them. No, I don't want to put 0 through 4 because that's then specifying that there's numbers in between. And this is a small enough pool that I can actually list all the numbers. The directions then tell me that I need the range. Well, the range isn't listed for me. There's no information for me. I find the range by taking each of these domains and plugging them in for X. So X is up here, and it's saying, okay, if I sell no tickets, 0 times 250, well, I don't make any money, so I'm at $20. If I sell one ticket, 1 times 250 is 250 plus the $20, I'm now at $22.50. I then plug in the 2, and I get $25. I have $27.50, and I have $30. My range will always be the result of the domains plugging in. And now I've answered all components of this question. So I have 2 UDOs for you, and in these UDOs, again, I want to know what is the function rule, what are the domains you're listing, and then what are the ranges that you get from them. Let's take a look at these. The temperature in the morning is 17 degrees Celsius. It increases 2 degrees Celsius every hour for the next 5 hours. Then we have Sammy. She is earning $8.50 per hour proofreading ads at the local newspaper. He works no more than 5 hours a day. So what would be the function rule? And then what would be the reasonable domain and ranges for these answers? All right, let's see what you get. All right, so let's create our function rules to start. So f of x, and then we have a 2-degree input, 2 degrees every hour, and it is already 17 degrees outside. All right, we have 5 hours passing, so my domain, make sure you're using your set appropriately. Our domain would be 0. Just kidding. Yes, 0, 1, 2, 3, 4, and 5. So at no hours passing, at 1 hour, at 2 hours, at 3 hours, at 4 hours, and 5 hours. Our range then is us plugging in those numbers. So if no time passes, it is 17 degrees outside. After 1 hour, it's 19. 2 hours, it's 21. 3 hours, 23. 4 hours, 25. And at 5 hours, we are at 27 degrees. All right, in the second one, we have f of x equals 850 each hour. And I'm working no more than 5 hours. Now, the answer key, which I was just reading over my shoulder, does not have 0. But I could earn no money. I could work no hours and not get paid. So I would still put 0, 1, 2, 3, 4, and we have 5. So then my range is the amount of money that I'm earning. So I'm earning no money. And then I would earn $8.50. I would earn $17, $25.50, $34, and then $42.50. So in this, we talked about independent and dependent, figuring out our function notation for writing things, and then we have to then use our skills of domain and range. All of this packaged into one big ball of fun. All right. So hopefully this video helped you out with what you need to do and figure out, and helped your brain kind of piece and part things together. And I hope you are then ready to give your answers however best you need.